So for a polynomial of degree n, you can use something called the nth differences in order to determine some information about the degree of the polynomial, as well as the sign and value of the leading coefficient. So for a polynomial of degree n, the nth differences will all be equal, and this will be equivalent to the degree of the polynomial. So whichever iteration of the difference that you are on will be the degree of the polynomial. For example, if I am doing the first differences and all of the first differences end up being 4, 4, 4, then the degree of the polynomial isn't 4, the degree is 1 because we stopped at the first difference. So the iteration of the differences that you're taking is going to be equal to the degree of the polynomial, not the difference itself. In addition to this, the nth differences are going to have the same sign as the leading coefficient, and you can actually back calculate the value of the leading coefficient, a, using this formula here, an factorial. So if you haven't seen something like n factorial before, a quick explanation of what a factorial is, it's like successively multiplying a number by itself minus 1. So for example, if I took 4 factorial, that's going to be equal to 4 times 3 times 2 times 1. So you keep subtracting 1 and multiplying it back in. If I had 3 factorial, it's going to be equal to 3 times 2 times 1. If I had 2 factorial, it's going to be equal to 2 times 1. And factorials are denoted with this exclamation mark notation here. So that's going to be relevant to know if you want to calculate the leading coefficient using nth differences. So let's take a look at this example here. We're given this chart of this table of values of x and y values for some polynomial function. And we're going to try to find the nth differences to determine some information about this polynomial. So let's go ahead and start by finding the first differences. So all we're going to do is we're always going to end up doing the second number minus the first number. So for example, our first difference is here, this jump from this term to this term. We're going to do negative 12 minus negative 36, and that's going to get us 24. So the first difference for this jump is 24. Now we're going to do the next jump. So on the next jump, we are going to have, oh, sorry, this should actually be a negative 2. That's my mistake. But on this jump, we're going to have negative 2 minus negative 12, which is going to get us 10, positive 10. The next jump that we're going to do, we're going to have 0 take away negative 2, and that's going to give us positive 2. On the next jump, we're going to have 0 minus 0, which is going to give us 0. And on the final jump here, we're going to have 4 minus 0, which is going to give us positive 4. So these values here are all of our first differences. And as we can see, just looking at these values, these are not all equivalent to each other. These are not all equal. So we need to keep going. We need to start taking second differences now, since these values aren't equal. And we're basically going to keep iterating differences, or taking, the next iteration of differences until we arrive at a point where all of the differences are equal. So right now they're not equal, so we're going to move on to the second differences. So we can also conclude now that it is not a first degree polynomial because the first differences are not all equal. So let's move on to the second differences. Let's see if it's a second degree polynomial. So let's do this jump right here. So for this, we're going to have 10 minus 24, and that's going to give us negative 14. For this jump right here, we're going to have 2 minus 10. That's going to give us negative 8. So we can already see they're not equal. For this next jump right here, we're going to have 0 minus 2 is negative 2. And for the final jump, right here, we're going to have 4 minus 0 equals 4. So again, here we can see the second differences. These are not all equal. So we know now that it's not a second degree polynomial either. And we have to move on to taking the third differences, since these second differences still aren't equal. So let's take the third differences. So for this first jump right here, we're going to have -8 minus -14 minus -14. And that's going to give us +6. The next jump here, we're going to have -2 minus -8. And that's also going to give us +6. And finally, we're going to have +4 minus -2, which is once again +6. So in this case, we can see that these are all equal. So our third differences are all equal. So we know that this polynomial has to be a third degree polynomial. So now we know the degree of the polynomial, and we have that our nth difference is equal to 6. So 6 is our nth difference. So now, what if we wanted to know the sign of the leading coefficient? Well, we know that the nth difference has to have the same sign as the leading coefficient. Since our nth difference is +6, we know our leading coefficient has to be a positive number. And in addition to that, we can actually calculate what that number will be. So what if we wanted to calculate our leading coefficient? Well, we're going to use that factorial formula from earlier. So we know that the difference, the nth difference, has to be equal to a n factorial, where a is our leading coefficient. So n, we have just discovered, is going to be 3. And that's because we stopped at the third difference. So our polynomial is third degree. So we know that n equals 3 in this case. And we found our first difference. We know that, our nth difference. We know our nth difference is 6 based on this value here. So we can plug in what we know. We know 6 equals whatever our leading coefficient is times 3 factorial. Now let's expand that factorial. So 6 is going to equal our leading coefficient times 3 times 2 times 1. All right, so now we know that 6 is equal to a times 6. And if we divide both sides by 6, we get that a equals 1. So we know that our leading coefficient is +1. So that's how you would use first differences or nth differences to discover the degree of a polynomial, as well as the sign and value of the leading coefficient.